Another example. Find the length of the tangents from 8, 5 to the circle x minus 2 squared plus y plus 1 squared is equal to 16. So this circle has center 2, -1 and radius of 4. Okay, so if I were to draw this out, so my circle has center to -1. Okay, really bad circle. So we've got somewhere out there is a point 85. This point makes a tangent somewhere here. We know where this touches the circle, the radius is equal to 4, so this length is 4. What we also know is that the tangent and radius meet at 90 degrees according to the circle theorem. That means if I join the circle center to this point 85, that makes a right angle triangle. Okay, so the first thing I need to do is work out this distance. Okay, now this distance is using the distance between 2 points formula. I end up getting change in x squared, so 8 minus 2 squared, plus change in y squared, added together square rooted, which means I end up getting square root of 6 squared, which is 36, plus 6 squared again, which is 36, which gives me root 72. So this is root 72. Now I'm trying to find the length of the tangent from 8, 5 to the circle, so I'm trying to find this length L. Now, using Pythagoras, I know that L squared plus 4 squared must be equal to root 72 squared. Okay, I don't know what L squared is, so L squared plus 16 must be equal to 72. Which means L squared must be equal to 72 take away 16, which is 56. So L must be equal to square root of 56. So that would be my final answer. The next example. It is given that the circle x squared plus y squared minus 14x minus 10y plus c is equal to 0 lies wholly in the first quadrant. Show that 49 is less than c, which is less than 74. So if I collect again the x's together, and then I complete the square, I end up getting x minus 7 squared, take away 49, plus y minus 5 squared, take away 25, plus c is equal to 0. If I collect the constants together, negative 49 take away 25 gives me negative 74 plus c is equal to 0. If I take the constants to the right hand side, I end up getting x minus 7 squared plus y minus 5 squared is equal to 74 take away c, which implies the center is equal to 7, 5, and the radius is root of 74 minus c. Now it says that this circle lies wholly in the first quadrant. So if I were to draw it out, then my circle center is 7, 5. Because it wholly lies here, it does not touch the x-axis or the y-axis. And I know this is the radius, which is root of 74 minus c. Or let's just label it as r. Okay, so what we do know is, first of all, because it's a circle, the radius must be greater than 0, which means root of 74 minus c must be greater than 0. This implies 74 minus c must be greater than 0 when we square both sides, which implies that 74 must be greater than C, which if you rewrite it the other way around, is C is less than 74. So that's the first part. We've got that part. We need to prove the other side. Now, because the radius does not touch the x or the y axis, what we do know is radius must be both less than 7 and radius must be less than 5, because the circle center is 7 and 5. Now, both of those combined means radius must be less than 5. Okay, so that means this implies root of 74 minus c must be less than 5. Now, if we square both sides, I get 74 minus c must be less than 25, which means 74 must be less than 25 plus c, which means c must be greater than 74, take away 25, which is 49. Okay, so this is the second one. Now, if we combine the two inequalities together, if we put them together, then I get 49 is less than c, which is less than 74, which is the final answer that we want. Prove that each of the circle x squared plus y squared minus 4x equals 0 and x squared plus y squared minus 12x minus 8y plus 43 equals 0 lies completely outside the other. Let's call this circle C1. Let's call this circle C2. Okay, so if we're looking at C1 first, then we've got x squared take away 4x. Rearrange it to get all the x's together and the y's together. So if I complete the square, I get x minus 2 squared, take away 4, plus y squared equals 0. If I rearrange it and take the negative 4 to the other side, I end up getting equal to 4, which means the center of C1 is 2, 0, and the radius is equal to 2. Okay, if I do the similar thing for C2, rearrange it, so x squared take away 12x plus y squared take away 8y plus 43 equals 0. X take away 6 squared minus 36 plus y take away 4 squared take away 16 plus 43 equals 0. X take away 6 squared plus y take away 4 squared, negative 36 take away 16 plus 43 gives me negative 9 equals 0. If I take the constant to the other side, I get 9, which means my center is 6, 4, and my radius is 3. Now, if I roughly sketch these, and because they're supposed to be lie completely outside each other, they can't intersect. So my first circle, if I draw it, I've got my circle center at 2, 0. My radius is 2. And my other circle is somewhere here. Doesn't matter where it is, but it's not inside, not touching the first circle, 6, 4. And the radius is 3. Now, if this circle lie completely outside the other, then if I work out the distance between the two circle centers, let's call this distance between circle 1 and circle 2, then if it lies completely outside each other, then distance of circle 1 and circle 2 must be greater than the two radiuses added together, so R1 plus R2. It has to be greater. It can't be equal. If it's equal, it must be touching. If it's less than, then it will be one inside the other. So I have to prove that the distance between C1 and C2, the centers, is greater than R1 plus R2. So let's work out first the distance between C1 and C2. So distance between C1 and C2 is equal to square root of the difference between the x coordinates. So it's 6 minus 2 squared plus 4 minus 0 squared, which gives you square root of 4 squared, which is 16, plus 16, which is equal to root 32. Now, is root 32 greater than the two radius added together? Is root 32 greater than 3 plus 2? Yes, it's true. So since the distance between the two circle centers is greater than the sum of the two radii, the circles lie completely outside each other. That would be the proof done. The next example, the circle C1 has the equation x squared plus y squared plus 4x minus 6y take away 12 equals 0. So let's first find the circle center and radius for this one. So I rearrange it first to get x's and y's together. Complete the square, so half the 4, I get x plus 2 squared. Take away the square of 2, which is 4. Half the 6, which gives me negative 3. Take away 3 squared, which is 9. Take away 12 equals 0. If I clean this up, I get x plus 2 squared plus y minus 3 squared. And then I get minus 25 equals 0. If I take the constant to the right hand side, I get is equal to 25, which means the center is minus 2, 3, and the radius is equal to 5. Okay, and the circle C2 has equation x squared plus y squared minus 20x plus 12y plus 100 is equal to 0. So again, if I do a similar thing for that one, then x squared take away 20x plus y squared plus 12y plus 100 equals 0. Complete the square. So half of minus 20 is minus 10. Take in the square of that, which is 100. Half of positive 12 is 6. Take away 6 squared, which is 36, plus 100 equals 0. If I clean this up, simplify the constants, they end up getting negative 36 equals 0. And if I take the negative 36 to the other side, I end up getting positive 36, which means the center is equal to 10, negative 6, and the radius is equal to 6. Now if I do a rough sketch, then the circle 1 has circle center minus 2, 3, and the radius of 5. So we will cross the x and y axis. And my second circle has circle center 10, negative 6, and the radius is 6. So radius is 6. Now the point P lies on C1 and Q lies on C2. So the distance between P and Q is denoted by D. Show that 4 is less than or equal to D, which is less than or equal to 26. So what we're trying to do is P and Q can lie anywhere. P can lie anywhere on the first circle. Q can lie anywhere on the second circle. So what we're trying to find out is what's the maximum value that the distance can take between P and Q, and what's the minimum. So we're trying to prove that. Now, in order to do this question, if I draw a line that goes through the two circle centers, then the maximum distance, which is d between P and Q, will happen when P is here and Q is there. And the minimum distance will happen when P is here and Q is there. So in order to work out these maximum and minimum distance, the first thing I need to work out is the distance between the two circle centers. So if I work out distance between two circle centers will be equal to square root of 10 minus 2 squared plus negative 6 take away 3 squared, which gives me 144 plus 81, which is equal to square root of 225, which works out to be 15. So that means the distance between the two points is, two circle centers is 15. So from here to here, I've got 15. So the maximum value of D will be this distance, which is 15, plus radius 1 plus radius 2, because we get this extra part here and this extra part there. So that is 15 plus 5 plus 6, which is 26. And the minimum value of D, if I were to use a different color, is this part. And now if I were to work this out, it's the same thing as this distance between the two centers, take away the two radii. So if I work that out, it's 15 take away R1, take away R2. So 15 take away 5, take away 6, which is the value 4. So these two together imply that D must be between 4 and 26. The straight line y is equal to 2x plus k meets the circle x squared plus y squared minus 2x plus 4y equals 0 at 2 points. If it meets at 2 points, it means b squared minus 4ac, which is a discriminant, must be greater than 0 for combined function. Find the set of possible values of k. So the first thing I need to do is substitute y is equal to 2x plus k into x squared plus y squared minus 2x plus 4y equals 0, which ends up giving me x squared plus 2x plus k squared minus 2x plus 4 lots of 2x plus k is equal to 0. If I expand this, I end up getting this x squared obviously stays as x squared. If I expand the first bracket, 2x times 2x gives me 4x squared. I end up getting 2xk plus 2xk plus k squared. I'm expanding the first bracket. Minus 2x, 4 times 2x gives me plus 8x plus 4k is equal to 0. Okay, if I clean this up, I end up getting 5x squared plus I get 4xk minus 2x plus 8x gives me plus 6x plus k squared plus 4k equals 0. So 5x squared plus, if I factorize the x out, I get 4k plus 6 lots of x plus k squared plus 4k is equal to 0. In this case, my a is 5, my b is 4k plus 6, and my c is k squared plus 4k. Now, we already said that b squared minus 4ac must be greater than 0, but because it meets at 2 points, which means 4k plus 6 squared minus 4 times 5 times k squared plus 4k must be greater than 0. If I expand the first bracket, I get 16k squared plus 24k, which gives me 48k, plus 36. 4 times 5 times k squared gives me minus 20k squared. 4 times 5 times 4k gives me, take away 80k is greater than 0. If I simplify this, I get negative 4k squared from 16k squared to take away 20k squared. 48k take away 80k gives me negative 32k, plus 36 is greater than 0. If I divide by negative 4, because it's an inequality, I need to flip the inequality over, so I get less than 0 now. So I get k squared plus 8k take away 9 must be less than 0. I'm going to go over here. So if I factorize that out, which is factorizes quite easily, I end up with k plus 9 times k take away 1 must be less than 0. So if I draw this quadratic, rough sketch of this quadratic, okay, my critical values are negative 9 and 1. It's a positive k squared bracket, so something like that. I want the part that is less than 0, so I want this part, which is one section of the graph, so it's going to be one inequality. So if I have to write this as an inequality, my solution would be k between negative 9 and 1. So the set of possible values of k which satisfy that condition is everything between minus 9 and 1. And my last example is here. The circle C has equation x minus 6 squared plus y minus 5 squared is equal to 17. The line L1 and L2 are each tangent to the circle and intersect at the point 0, 12. Find the equations of L1 and L2, giving you answer in the form y equals mx plus c. Now, because these lines, these tangents, go through 12, they have the form y equals mx plus 12. Both of them y equals mx plus 12. Also, because they are a tangent, they meet at one point, which means b squared minus 4ac must be equal to 0. Okay, first thing I need to do, because we're trying to obviously combine the function, I need to substitute y equals mx plus 12, which is the general equation for these two tangents, into the equation of the circle, which is x minus 6 squared plus y minus 5 squared is equal to 17. So when I do that, I end up getting x minus 6 squared plus mx plus 12, so replace the y with mx plus 12, minus 5 squared is equal to 17. So if I simplify the second bracket, I end up getting mx plus 7, mx plus 7 squared is equal to 17. If I expand the bracket, first bracket, I get x squared, take away 6x, take away 6x, which gives me negative 12x plus 36. If I expand the second bracket, I get m squared, x squared, plus 2 lots of 7mx, which is 14mx, plus 49 is equal to 17. If I take everything to the left-hand side, I end up getting x squared plus m squared x squared minus 12x plus 14mx, 36 plus 49, take away 17, gives me positive 68 equals 0. If I factorize the x squared out, so I get 1 plus m squared times x squared, plus factorize the x out, I get 14m take away 12 lots of x plus 68 is equal to 0. Now in this case, my a is equal to 1 plus m squared, my b is equal to 14 m take away 12, and my c is equal to 68. And I know that we've already discussed that b squared minus 4ac must be equal to 0. This implies that 14m minus 12 squared minus 4 times 1 plus m squared times 68 must be equal to 0. Okay, so if I expand this out, I get 196m squared, take away 336m plus 144 minus 272m squared, take away 272 equals 0. If I simplify this, I get 76m squared plus 336m plus 128 equals 0. And I get this by taking everything to the right hand side. I can divide by 4 now, which gives me 19m squared plus 84m plus 32 equals 0. Now using your calculator and quadratic formula, using a is equal to 19, b is equal to 84, and c is equal to 32, m is equal to minus b plus or minus root of b squared minus 4ac all over 2a, which is minus 84 plus or minus root of 84 squared minus 4 times 19 times 32 all over 2 times 19, which gives me a value of m is equal to negative 8 over 19 and m is equal to minus 4. Okay, which makes sense because both the gradients are negative. Okay, so when m is equal to negative 8 over 19, y is equal to negative 8 over 19x plus 12. And when m is equal to negative 4, y is equal to negative 4x plus 12. So these are the two equations you get for the line L1 and L2.